Hello, so I have tried to analyze the top-down pile driver demolition. There was an example on the internet called Verniage demolition, which was done in France. I used a software called Tracer, which is a physics software. It traces the motion. I calibrated by guessing because I wasn't able to obtain information about the building. And I ran the tracker to find out what will happen, whether we'll have a deceleration, acceleration, and how the speed will change in the case of a top-down pile driver progressive collapse. This is, as you will notice, this method requires the demolition team to sever the building right in the middle, so that the pile driver is of equal size to the lower intact structure that it intends to destroy. This makes sense in accordance to Newton's third law, so that in the process of destroying the lower intact structure, its own bonds of the pile driver will break in the process, and both of them will be destroyed. However, in North Tower, we have 10 floors, allegedly, we have a 10 floors pile driver, allegedly destroyed 90 intact floors below it, which is simply impossible, because at 10 floors, without the assistance of demolition, 10 floors can at best destroy a further 10 floors, and the collapse is expected to be arrested. So this is the case. This is my position versus time. I run the animation. This is the tracking. They sever the center, top section, the same size as the bottom section. They destroy each other. There's no problem with that. This is right. A lot of the people defending the official theory, they use this video. Okay, this doesn't prove anything. So now the problem is, let's look at the analysis of this. I assumed every floor is 3.7 meters. It will give me velocity. We're interested in the y direction. This is the velocities. At the start, this is the onset of the collapse. There's up and down. It's all negative because we're going downwards, so our velocities are negative. So we have negative 2 meters per second, negative 8, negative. The maximum velocity we go is around negative 20. Negative 16, negative 20. And then we're slowing down. Here, slowing down. See, the line of best fit is slowing down until it reaches about negative 14 meters per second. Negative 14 meters per second is almost like somebody running. Like the fast running person is about 10 meters per second. So this is nowhere near the speeds, the enormous speeds that we witnessed in the 9/11, in North Tower, or Building 7. Building 7 was free falling for 2.5 seconds. According to David Chandler's analysis, he showed that free falling for 2.5 seconds of the entire journey, which makes it reach high speeds. Now we'll look at the acceleration. Acceleration in the y direction. This is the acceleration. As you see, it's all going around the zero. Here, it's negative means acceleration, positive means deceleration, slowing down, because we're going downwards, the motion. So here we have negative half meters per second squared. Then we get a jolt, as they say, like slowing down. Here going up higher than zero, like positive, which means slowing down, speeding up, slowing down, speeding up, slow. I'm assuming that these waves are actually each time the structure, the pile driver, first it's given an empty space to accelerate and impact the lower structure. When it first impacts it, it needs to overcome the strain energy of the structure and deform the structure beyond its elastic limit and buckle the columns or whatever walls there until they buckle. And when they start yielding, the pile driver will start speeding up again. But at the process of overcoming the strain energy, it slows it down because it will absorb a lot of energy from the kinetic energy that the pile driver has come with while it's accelerating. So it will slow it down, overcomes the strain energy, buckles it, yields, breaks that first floor columns, takes it to the failure point. Then that's the speeding. Then when it reaches the next floor, again it's encountered by new columns and structure intact, which will need to overcome the strain energy again, and then it slows down again, and then it speeds up. So that's normal and expected from this type of gravity demolition. And here, so we go here, that's when that big section is taken away. That's how the collapse has been started. When it reaches here, this is when it encounters the serious, okay, go here, and then I think here, this is where it encounters some serious resistance. As you see, it slows down heaps, it go there. Why is it slowing down so much? This is when it's encountering an intact structure, and now it's all slowing it down, and then here is probably overcome the structure. It speeds up again and slows down and speeds up, slows down, and generally it's around the zero. Now if my calibration is wrong, let me make it, some people were saying this, I couldn't get the dimensions for this building. Some people were saying, oh, this building's around 20 meters or some, 250 meters or something, which makes my scale way off. So just to be sure, I will put the other scale, which let's say every floor is 10 meters. I highly doubt it, because when you have each floor is so high, the slenderness ratio is gonna make your buckling problem, like you have a buckling problem. You can buckle the vertical members really easily. So they wouldn't put every floor like 10 meters. Okay, let's say 10 meters. If I say 10 meters, again, the scale has changed, as you see, but we have reached down to -2, -3, let's say. That's the highest acceleration we got, but nowhere near -9.8, which is the acceleration of gravity, which is achieved only at free fall, where your pile driver is falling through nothing. So when your pile driver is falling through nothing, how can that be achieved without actually removing the intact structure below it out of its way before it actually encounters it? If it's left to encounter it, this is the sort of result we would expect. We would expect deceleration, and we would not expect like anything like an acceleration close to the acceleration of gravity. In the North Tower, there's much more problems, apart from the symmetrical global collapse, which is impossible in the cases of asymmetrical damage. What you would expect is that the pile driver, the alleged pile driver, would actually topple, pitch and tip over, rather than symmetrically going through 90 floors. It's only 10 floors, going through 90 floors, something 9 times its own size, and not only its own size, the building gets stronger and stronger as you go down. And 9 times, even if we say its own size, it's simply impossible. The only way was that those 90 floors moved out of the way. And this is in the case of North Tower. Even the South Tower, the South Tower is different. We can't argue about, because it was hit in the middle. We can't say, oh, the pile driver is too small. They're going to say, oh, the middle means there's a huge mass and thing above it, which is equivalent to what's below, like this one, like this video. So it is possible, theoretically, if you remove enough floors. However, the problem with South Tower, when you observe what happened, first it encountered some resistance, so it tipped over. And it started gaining angular momentum, and you have pictures where it's leaning so much. And then what will happen when it's leaning? It's a block of the pile driver above the damage zone. It's a block of building. Nothing's wrong with it. It's leaning, so it's supposed to keep going. The conservation of the angular momentum is supposed to keep going and tipping over. But that's not what happened. What happened was it just disintegrated in mid-air, which means there's explosions or something inside it which just damaged it. And the other issue is the speed. The speed, so as you see here, even in the worst case, we have acceleration of -2, but it slows down to positive and then negative. So the average here, as you see, the line of best fit is, we can say, is 0 or a little bit less than 0. There is no acceleration. So if the North Tower was a pile driver progressive collapse, as they claim, then you will need a good 40 seconds for that to happen, because you're not going to have any acceleration. So in reality, it happened in 11 seconds, which is close to the, not exactly, but a little bit slower, but it's close to free fall, which is impossible. And there's plenty of other problems, but I will leave it at that for now.